Today we're going to be working on Unit 8, Notes 1. So we're going to be talking about simplifying radical expressions. So first thing I want to do is just kind of review the prime factorization of numbers. So when you do the prime factorization of numbers, what you're aiming to do is to break a number completely down so it is being multiplied by all primes. So I want to kind of think about, okay, what divides 63? So I just start dividing 63 by random numbers. And when I do that, I figure out that 9 and 7 divide 63. Well, 7 is already a prime number, so I can leave that one. That's the end of that leg. And then 9 now I can break down to 3 and 3. Well, 3 are both prime numbers, so that's the end of that leg. Since I've gotten to the end of every single leg, that's my final answer. So then I'm going to have 3 times 7 as my prime factorization on the first one. Now let's take a look at number 2. We're going to do the prime factorization. Well, whenever I see an even number, to me the easiest thing to do is to divide it by 2. So when I do that, I get 2 and 49 multiplied to 98. And then I want to break down 49. Well, 49 breaks down to 7 and 7. So at the ends, I have 2, and then I have 7 and 7. So the prime factorization of 98 is 2 times 7 times 7. Now, let's take a look at 180. So here's a trick I use with 180. So because 180 has a 0 on the end of it, then I know that it is divisible by 10. So I'm going to go ahead and divide it by 10, and when I do that, I get 10 and 18. So I'm breaking this guy down to 10 and 18. Well, 10 I can break down to 2 and 5. Now, 2 is the only even prime number. Remember that prime numbers are numbers that can only be divided by themselves and 1. So this leg stops here because they've all been broken down. Now let's take a look at 18. 18 I can break down to 9 and 2. So this leg's done here because 9 is a prime number, or 2 is a prime number. 9, however, is not. So I'm going to break that down to 3 and 3. And when I'm writing out the multiples, I like to write them in numerical order. So I'm going to have 2 times 2. That gets rid of those. Remember, you're looking at every single end. And then we're going to have 3 times 3. Got rid of those. And then I'm going to have 5. So you're looking at every single end of each leg. So how does this help us with radical expressions? Let's go ahead and let's take a look at that. So a radical expression is any expression with a radical term. That's a radical right there. That's when I say radical, that's what I'm talking about. It's a square root sign. Okay? Simplified form of the radical. There's no perfect squares underneath the radical. No fractions underneath the radical, and no radicals in the denominator. Okay, so those are good forms. So when you're done and you think you're done simplifying a problem, that's a good check to go through. Okay, are all of those true? If they're not, then you still have more simplifying to do. When you go to simplify rational expressions, do the prime factorization of the number. If there's a variable in the power, you're going to write it in expanded form. What do I mean by expanded form? Well, expanded form, for example, if I have the square root of x to the third, to write it in expanded form, I'm going to write x to the third as 3x's being multiplied. Now that's going to help me find my perfect squares. And lastly, pull out any pairs. And we're going to talk about what pulling out paired means when we get a chance to go over this. So if you need to take a second and pause to write the rest of this down, please feel free to do that. So let's go ahead and let's take a look at simplifying these expressions here. So what I want to do is I want to break down this 50. I want to do the prime factorization of this 50. So what divides 50? Well, 10 and 5. If it ends in a 0, you know it's divisible by 5. 5 is a prime number. That's the end of that leg. Well, 10 I can break down to 2 and 5. Both of these are prime numbers. Those legs are ending. So now all of my legs have ended. So underneath the radical, I'm going to have 2 times 5 times 5. So now we talked about pulling out the pairs. So here you see I have a pair of 2 5s. So I like to look at it this way. Look at this radical as being a jail cell. Okay? In order to break out of the jail cell, you have to have a partner in crime. So we're going to break out of the jail cell as a partnership. Once we're outside of the jail, we're going to become 1. So I took those pair of 5s out, and when I did that, notice I just wrote 1 5 on the outside. Now the 2 didn't have a partner to break out with, so it has to stay in jail. So this right here is your final answer, 5 square root of 2. What I don't want in any of this unit is decimals. I'm looking for simplified radicals. You don't write the decimal of the number. So let's go ahead and let's take a look at the square root of 48. So I don't really know what divides 48, so I think I try playing around with numbers on the calculator, and I end up getting 6 and 8. Well, 6 I can break down to 2 and 3. Both of these are prime, so that's the end of that leg. 8 I can break down to 4 and 2. Well, 2 is prime, so that's the end of that leg, but I still have to break down 4 even further, and 4 is going to break down to 2 and 2. So I count, I have 1, 2, 3, 4 2's. So underneath my radical, again, I'm going to put it in numerical order. I'm going to write out 4 2's. Don't forget that up there I also have that 3. When you pull it down into the radical, you want to get the end of every single leg. So I have 1 pair of 2's and 2 pair of 2's. Each of those 2's are going to break out of jail. So I'm going to have a 2 here, but then I'm going to have another pair of 2's. Since I have 2 pairs of 2's, I have 2 2's written out there. Now notice that they're being multiplied together. And that's going to be times the square root of 3. Well, 2 times 2 is 4, and then underneath that radical is going to be 3. So your final answer there is 4 square root of 3. Again, we don't want decimals. So let's take a look at the square root of 32. So what divides 32? Well, that's going to be 4 and 8. You could also use 16 and 2. It doesn't matter which pairs you choose, just that you choose a pair. So we're going to take 4 and break it down to be 2 and 2. We're going to take 8 and break that down to 4 and 2. And then 2 and 2. Remember, to be at the end of every single leg, you have to have a prime number. So we have 1, 2, 3, 4, 5 2's. So underneath the radical, I'm going to write out 5 2's. So I have a pair of 2's here and a pair of 2's here. So I can take each of those pairs because they have a partner and pull them outside of the radical. So I end up having 2 times 2 on the outside of the radical, and then underneath I have 2. Well, 2 times 2 is 4. So I end up getting 4 square root of 2 when I simplify the square root of 32. Let's just for kicks, let's add some letters in there. How does that work? Well, if you remember in the original, when we were talking about radicals, we talked about simplifying it. You need to expand. So x to the 4th is same as x times x times x times x. So there's 4 x's. So now that I've written that out, I'm going to go ahead and make my pairs. So I have a pair of x's here that I can take out, and I have another pair of x's there that I can take out. What you'll notice here is that there's no more x's left underneath the radical. There's nothing left underneath the radical, which means my radical is going to be gone altogether because everything came out in pairs. So I have an x here, and then I have an x here. So x times x is going to be x squared. So that's my final answer for number 7. Now, taking a look at number 8, I'm going to take and I'm going to break down 4 into 2 and 2. Okay, now 2 and 2 are both prime. So now I'm going to write everything out underneath the radical. Well, I'm going to have 2 times 2. And then I have 3 b's. So I'm going to have b times b times b. So I have a pair of 2's I can take out, and I have a pair of b's that I can take out. So I'm going to take out 2, and then that's going to be time b. Now notice I still have a leftover b, so that needs to stay underneath that radical symbol. Well, 2 times b is simply going to be 2b. Or not 2b, just kidding. So then I have 2b times the square root of b. So let's go ahead and let's take a look at number 9. So the first thing I want to do on number 9 is break down that 75. So I know that goes into 75 is 25 and 3. If you're not sure, there's a 5 at the end. You know 5 goes into it. 25 is going to break down to 5 and 5. So at the end of each leg, I have a prime number, so that means I'm good to write out my radical. So I'm going to have 3 times 5 times 5, and then I'm going to have 2 x's to represent the x squared, and 3 y's to represent the y cubed. So now I'm going to find my pairs. I have a pair here, and a pair here. Now each of those are going to come out of the radical and become 1. So then I have 5, I have x, and I have y. And then left underneath the radical is 3y. So that's my final answer for number 9. Now let's continue looking at this. So simplifying radical expressions using perfect squares. So if you can find perfect squares within the number you're simplifying, that will make this a lot easier for you. So first of all, you want to determine the largest perfect square that divides a number. And then you can use the product property to rewrite the radical expression. Take the square root to simplify. So this process that we're talking about here does not work for variables. And it actually really is going to be the same thing that we're doing here. Okay, so really, for example, if we have the square root of 4 times 6, that's going to be the same as the square root of 4 times square root of 6. Well, square root of 4 is 2, so that just becomes 2 square root of 6. This really isn't anything different. It's just more convenient if you do know your perfect squares. So let's go ahead and let's write out some of these perfect squares. Well, 1 times 1 is 1. 2 times 2, 4, 9, 16, 25, 36, 49. Now, all of these are really key numbers that you're going to want to look for as you're going through these. 64, 81, 100, 121, 144, 169, 196, 225, and yes, in case you're wondering, I am multiplying these by heart. 256, just kidding, no I'm not. 289, 324, 361, and last but not least, 400. So let's go ahead and let's take a look at number 10. So we're going to simplify this out. So I'm thinking, okay, when it comes to 24, are there any perfect squares that divide 24? Yeah, 4. Okay, so I'm going to make sure I focus in on 4. So then I split that up into 4 and 6. Well, 4 I know is going to go into 2 and 2. Well, that's going to give me a pair. So I'm going to leave the 2 times 3 underneath the radical because I already know that I can take a pair of 2's out. So then I end up getting 2 times the square root of 6. This is the exact same example that I used when we did that practice of the product property on the other sheet. So let's take a look at 11. Is there a perfect square that goes into 11? And there is. It's 49. So I'm going to break this into 2 and 49. So because I'm using 49, I automatically know I'm going to have a pair of 7's. And those pair of 7's can plop onto the outside of the radical, and then what's left underneath the radical is the thing without the pair. So that's just going to be 7 square root of 2. So now I have a number out in front, and it's really actually not that different. It's going to be very similar to what we're already doing. So then we're going to take 3 times the square root of 18. Well, I need to break down 18. Is there a perfect square that goes into 18? In fact, there is. It's 9. So we have 9 and 2. So now I need to take 9 and break it down into 3 and 3. So now I know because of that 9 I have a pair of 3's that I can take out. Well, notice that there's already a 3 on the outside of the radical. I need to take my pair 3 and I need to multiply it by the 3 that's already on the outside. So that's where I get the 2 3's from. One from here and one from up there. Now left underneath the radical is the thing without the pair, which is that 2. So 3 times 3 is going to give us 9, and then you're going to have the square root of 2. So 9 square root of 2 is your final answer on number 12. Now let's take a look at number 13. So I want to think, is there a perfect square that goes into 12? And in fact, there is, 4. So I'm going to break this down to be 4 and 3 because I know 4 is going to give me that pair of 2's that I can take out. So I'm going to take my 5 that's originally on the outside and I'm going to multiply it by my pair of 2's that I took out, and then left underneath the radical is going to be 3. So 5 times 2 is 10, and then I have the square root of 3. So that's your final answer for number 13. Now, let's take a look at this problem here. It says a tsunami is destructive, fast-moving ocean wave caused by the undersea earthquake, landslide, or volcano. Scientists predict that the time of the tsunamis by using water depth to calculate the speed of a tsunami. The model speed s in meters per second at which a tsunami moves is s is equal to the square root of GD, where D is the depth in meters and G is 9.8 meters per second. Whoops. There's a line. Okay, so let's take a look at this one. Find the speed of a tsunami in a region of the ocean that is 1,000 meters deep. So what we're going to do is our speed, I need to use a different color. Our speed is equal to the square root of our depth, which is 1,000, times our gravity constant, which they gave us to be 9.8. So when I multiply those together, I end up getting the square root of 9,800. So now we're going to go ahead and we're going to take the square root, and we're going to try and simplify that. We're not going to take the square root as a decimal. We're going to break down that radical. So between 9,000 and 800, you can take out 100. And I know that because of the 2 zeros that are at the end. So I can take out 100 here, I know that for sure, and then I have 98 here. Well, 100, I did that because it's a perfect square, and I can break that down to 10 and 10. Now, you could continue breaking this down into prime factors, but 10 and 10 is already a pair. So I'm going to stop there because I know I can take out a pair of 10's. So 98 I can break down to 2 and 49, which is fantastic because 49 is another perfect square, which I can break down into 7 and 7. So underneath my radical, I'm going to have 2 times 7 times 7 times 10 times 10. So I can take out 7 and 10. So then 7 times 10 is 70 when I bring them out to the outside. And then I have square root of 2. And then it's going to be meters per second because that's our label for our speed. So let's now go ahead and let's take a look at part B. So find the speed of the tsunami that's 4,000 meters deep. So it's 4 times as deep. Let's go ahead and let's take a peek at that one, shall we? So when we do that, we're going to take the square root of 4,000 times our gravity constant, which is 9.8. Now, when we do that, we end up getting 39,200. So now we're going to break that. Again, I see the 2 zeros at the end, so I know that 100 divides it. And then I'm going to have 392 here. So I can split this down to 4 and 98. Now I chose 4 because 4 is a perfect square. And if I don't know what multiplies into these, I just take the time and I just start dividing it by perfect squares to see if I can find a pair to take out of it. Okay, so 98 I already know I can divide between 2 and 49, which breaks down to 7 and 7. And then 100 I can break down to 10 and 10. So underneath that radical, I'm going to have 2 times 2 times 2, there's another 2, don't forget that 2 there, times 7 times 7 times 10 times 10. So we have 1, 2, 3. So we have 3 pairs we can take out. So on the outside, 2 times 7 times 10, and then left underneath the radical is 2. So then I'm going to have 140 square root of 2, and then my label is going to be meters per second. Now let's take a look at that last critical thinking piece because I know how much you guys like to think critically. It says, is the speed of the tsunami in water that's 4,000 meters deep, the 4 times the speed of the tsunami that is 1,000 meters? Well, let's take a look. So we have 4,000 meters is going to be at 140 square root of 2 meters per second. 1,000 meters is going to be at 70 square root of 2. So if you look at 140 and 70, they are actually only double each other. So that's not the same as 4 times it. But if you think about it, we took that 4 times when we put the 4,000 in, and we put it underneath the square root. Well, 4 times, what's the square root of 4? It's 2. So that's why 4 times the amount of depth only became double the amount of speed because we took the square root of that. So take that. That's pretty cool, isn't it? So that concludes your note video for today. Thank you for listening.